5-number summary. Well, this is another form of variation, or measure, I should say, of variation. So how does this work? Well, we're just going to borrow the concept of the range and make it smaller, in a sense. So the 5-number summary is similar to the range concept, but broken up into smaller chunks to provide more what? Detail and variation within the range. The data is broken up into orders. The 5-number summary consists of these 5 values. The minimum, quartile 1, quartile 2, quartile 3, and finally the maximum. Now quartile 1 can be expressed as Q1, quartile 2 is known as the median, and quartile 3 is abbreviated Q3, minimum, sometimes you'll see it as min, and this is max, no surprise. All right, so how do we do this? To find the 5 numbers, let me first find the median of the ordered data set. This will divide the data into, well, sorry, in half, not into, in half. Okay, so now we found the median, we divided the data in half. What do we do next? So step 2 is find the median. Wait a minute, again, no. The median of the lower half. This will be quartile 1. Then the other step is find the median again, but of what? Of the upper half. This will be quartile 3. Okay, so really what we're doing is finding 5 numbers. Minimum, quartile 1, quartile 2, quartile 3, maximum. Each time dividing the data in half. So this divides it in half, and then we have an upper half and a lower half. And then we divide it in half again, both sides, is the 5-number summary. Well, let's just look at this. How does that tell us anything? How is it a measure of variation? So we're going to go back and look at the population data above in the pages above you. What I'm going to do here is, let's see, how many values were here? There were 56, that's right. N was 56, counted last time. Okay, so we're going to find the median of this data set. So my position of median. So that's going to be 56 plus 1 divided by 2, and that gives me 28.5. So position 28.5. So let me come back up here and start counting. I've got 12. I got 24, 24, 25, 26, 27, 28, 29. So the median is between these 2 values. That's the median. So now I'm going to read those 2 values. It's equal to 3.57 plus 3.96. Divide those by 2. And I get 3.765 million. So now that I've found the median, notice I have 28 values below, 28 values above. And if you don't see that, just count, and you'll see that there's 28 below and 28 above. So now I'm half 28 above, 28 above, below. So this is now my new sample size. So I find the median again, but of like 2 different sets. So position of quartile 1 or Q3, because they're both going to be in the same position respectively. All I'm going to do is take 21 plus 1, divide that by 2. That gives me 14.5. So I need to find the average of position 14 and position 15. So I'll go back up. I got 12 here, 13, 14, 15. So right here is quartile 1. So position quartile 1 is just going to be the average positions 14, which is 1.34 plus 1.36. Average those, and I could do this in my head, 1.35. So there is quartile 1, 1.35. Now, the position was between 14 and 15, the average of position 14 and 15. So Q3 will now just be the average of position 14 and 15, but in the upper half. So I'm going to go over here and let's see. I'm going to just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 14, 15, the average of those two numbers. So 6.95 plus 7.28. Divide those by 2. And what do I get? 7.115 million. So I have found quartile 1, the median, quartile 3, the minimum and the maximum are pretty self-explanatory. So I'm going to turn the page and copy all these values in the other page. So I've copied my numbers over, and now we're ready to interpret this. I'm going to draw a little number line here. This is obviously not correct in the sense of the distances, so please keep that in mind. But here's the median, and what does the median do? It separates the lower 50% from the upper 50%. But what did I do here? I separated again the data in half. So this is 50%, so half of 50% is 25%. So what does this number do? It separates the lowermost 25% from the next 25%. Below the median is 50%, 25 plus 25. So above the median, we have exactly the same thing. This separates the uppermost 25% from the next 25%. So basically, we have divided the data into quarters. That's what the 5-number summary does. Now the question is, what does that tell us about variation in the population of states? So the trick is to look at the differences. So if I looked at 1.35 minus 0, just like we did for the range. So this is a variation on the range concept. So the range, what do? We looked at the differences. So here we got 1.29 million. And now remember, this is distance, first part. Then we look at another range. Yeah, I'm going to look between here and here. Let's just kind of compare these two. This seems like a smart thing to do. So I can keep going here, but so basically I'm looking at the lower 25% and comparing it to the upper 25%, meaning 25% of data is in this range right here, and 25% of data is in this range right here. So what I notice is that the upper 25% has a lot of spread. It can go anywhere, well, there's a range of 32 million versus the lower 25%, which only has a spread of 1.29 million. So the lower 25% contains a quarter of the information, but spread out in this range right here. It's very tight, while the upper 25% has a huge range. Okay, so what we're looking at is the differences. We can also look at this difference if we wanted to. I'm not going to do that right now to save some time. But there's another difference that I do want to look at. I want to look at the difference between this number and this number. And this distance right here has a name, and that is the IQR. And that means the interquartile range. What is the interquartile range? Well, it's going to be Q3 minus Q1. So again, I'm taking a difference between the two numbers. And this contains the middle 50% of the data set. So notice this is where the center is located, which is the median. If I looked at for this particular data set, Q3 minus Q1, and I would get 5.675 million. So what does this tell me? The first 25% is very tight. The middle 55% is ranges between, it's a range of 5.675 million, but the upper 25% has a range of 32 million. Again, I can see that the upper range, the variation in the upper range is huge. And also notice that I can use this center, this IQR, as we're going to see, as a ruler. But before we do that, let's just do one more time, finding the 5-number summary. Okay, so now we have exam scores here, 27 exams, find the 5-number summary. Oh, the position of the median, let's find this first. 27 plus 1 divided by 2 equals 14. Well, that's nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is my median. So the median equals 0.811. Now, position of Q1. Well, position of Q1, what have we done? This number is the median. That was position 14. That leaves 13 values sitting below this number. Because the median, it's one of the actual values, it sort of disappears for the moment. It doesn't really disappear. It's just that we're not going to count it when we figure out Q1 or Q3. So I'd have 13 values below this number and 13 values above. So the position now of the median of these 13 values is going to be 7. So now I count 1, 2, 3, 4, 5, 6, 7. This is now the lower half. Quartile 1 is going to be 0.776. Will software do this for you? The answer is yes, but it's a really good idea right now to do this not using software. Also, understand that there's different variations on how to find this 5-number summary. The median is always going to be the same. Minimum, maximum, of course, they're going to be the same. But the quartile 1 and quartile 3 algorithms vary. I am using right now the algorithm that now seems to be the most popular, which is find the median again, and then find the median one more time. The median for the quartile 3 is also going to be in position 7. So 1, 2, notice I'm not counting this median. I'm starting here. 1, 2, 3, 4, 5, 6, 7. And that's quartile 3. Quartile 3 is 0.903. So my 5-number summary is going to be 0.406, 0.776, 0.811, 0.903, and finally 0.974. And just like I did before, what we want to do is look at the differences. So I can see that there's a 30.3, nearly 0.37 difference. While here, the difference is about 0.04. Here, the difference is about 0.09, and finally about 0.07. So this one between quartile 1 and the minimum, that has the biggest spread. The numbers are further apart. So this is how you calculate the 5-number summary. And now next, we're going to show you how we use that to determine outliers. So the 5-number summary is just a measure of variation by taking the range concept and making it into smaller chunks, for lack of a better word. But we're separating the data into quarters. Quarters.